Okay. We are continuing from what we were doing yesterday. We are still doing circuits. Today's lesson will look at electrical circuits and truth tables. We'll also investigate the relationship between voltage, current, and resistance. Okay, let's just recap on what we did yesterday. This is a circuit. I hope that you can identify the graphic symbols for the components. It's something that you were doing from grade 6. And now in grade 9, you are quite familiar with these symbols. How does the increasing number of lamps in series change the current and voltage in the circuit? We did that yesterday. Can you answer this question? In your own words, in your own understanding, tell me how the increasing number of lamps in series change the current and voltage in the circuit. Grade 9, hello. Let's see who's here. Okay. Okay. Don't you want to talk to me? Okay, let me just ask, what effect does a series connection have on the lamps? What is it that you see on the lamps which are connected in series? The light becomes dim. Okay, so why does the light become dim? This is how you explain it. The overall voltage drop, it's a voltage drop. The overall voltage drop across the lamps remains the same, but the current decreases. Now, let us see what that means. What is the voltage of the circuit? It's 4.5 volts. It's 4.5 volts. And that is the same throughout the circuit. Okay? But current, it decreases. Why does the current decrease? Because it is shared by these lamps. If all the lamps have the same resistance, if they have the same value or capacity, if they will offer the same resistance in the circuit. If they have the same resistance, the voltage drop across each lamp will be 1.5 volts. So they will be dividing the voltage. Okay, you see there are 3 cells here. Each cell is 1.5 volts. So the total voltage will be shared by these if they have the same capacity. You know, components have different values. You'll see when you go to an electronic shop and buy components, they will ask you what value. And even when you connect circuits, we will specify, right now in grade 9, we will specify the value of the components that you must connect. So even lamps, they have different values. So if these are of the same value, if these lamps are of the same value, they will each take 1.5 volts from these 4.5. They will take 1.5 each if they are equal. When the voltage drops, all the lamps are added and the total battery voltage of 4.5 volts is obtained. The current is the same through each lamp. So the current will be 1.5 volts, 1.5 volts, 1.5 volts, if they are equal in value. So if you continue to add more lights here, it means each and every lamp will be having a dimmer light. If the lights are equal, they will still continue to share this 4.5 volts. Lamps in parallel. In lamps in parallel connection, they are not like the lamps in series. Okay. So these lamps, they are getting 4.5 volts, okay, because in the whole circuit, there is 4.5 volts. Depending on their capacity, they will be getting the current. We measure current in amp, and they will not be sharing. They will not be sharing. And even if you can connect 3 lamps, they will not be sharing. So the current is divided across each lamp. The total current is the sum of the current through each lamp. So each lamp will be getting a total current of the circuit. Okay? So lamp total equals to lamp 1 plus lamp 2 plus lamp 3. So they will be getting the total voltage, the total current from the power source. That is why we have parallel connections of lights in our houses. And we are still recapping from yesterday. Understanding parallel connections, look at the circuit diagram below and answer the following question. Okay. What is the total voltage drop across lamp 1 and lamp 2? Can you answer that? This is a parallel connection. What is the total voltage drop across this lamp and this lamp? Grade 9, are you with me? Kwezi says it's 0. Okay, let me take you back here. Let me take you back here. We said here the total voltage drop across the lamps is the same. It's 4.5. In the whole circuit is 4.5. But these lamps will be sharing from the 4.5. Each lamp will be taking maybe 1.5 volts. 1.5 volts because they are connected in series. Okay, and here the voltage drop in the whole circuit is 4.5. Just that each lamp will be taking a voltage of 4.5. Even here, each lamp will be taking a voltage of 4.5. Now, we have this one. It's a parallel connection. The question is, what is the voltage drop across lamp 1 and 2? Let's see. Okay, Kwezi, all right. The voltage drop across each lamp is 4.5 volts, okay? it will actually be less than that because of internal resistance of the battery. Like sometimes if you take a 9V battery, use your multimeter to measure the voltage. Sometimes you may not find 9 volts. Okay, it can be lesser, but I've seen voltage being more. So the voltage that you will find in these lamps is the voltage of the circuit. When you measure the voltage in this lamp, when you take and you measure the voltage in this lamp, it will be the value of this power source. And even this one, it will be the value of this power source. Why? Because this is a parallel connection. Okay, I hope you understood that. They don't share, they don't split it because they are not connected in series. It is the ones that are connected in series that split the voltage of the circuit. The total current in the circuit is 10 amps. Just in another circuit, we are imagining. Lamp 1 has a current of 4 amps flowing through it. What will the current be through lamp 2? And obviously, these lamps are not of the same size. They're not of the same value. So what is your answer here? Grade 9. What is your answer here? It's 10 amps minus 4 amps is equal to 6 amps. So lamp 2 will be having current of 6 amps. Okay, switches in parallel. In the circuit below, there are 2 switches in parallel. This also gives us 4 different switch combinations. Complete the truth table for the circuit, okay, in this slide. For this circuit, what is the, let us discuss it. Okay, if input A is closed, is open, if input A is open and input B is closed, will there be light in the output in the lamp? What did you say yesterday? Grade 9. If this circuit is like this, what will be the output? There will be an output. Yes, there will be an output, okay? If input A is closed and input B is closed, will there be an output? If input A is closed and this one is open, will there be an output? Grade 9, come. Will there be an output? If we close A and open B, will there be an output? Okay, let me show you the truth table for this. I want you to understand an output by 1. I'm back. I was kicked out. I'm back. Okay. I'm here. So this is the truth table. If there's no output, we indicate by 0. If there's an output, we indicate by 1. So if input A is open, input B is open, will there be an output? No output. If input A is open and input B is closed like it is now, will there be an output? Yes. If input A is closed, input B is open, will there be an output? Yes. If both the inputs are closed, there will be an output. So what do we call this? We call it the end, the O. We call it the O. It's an O connection, OR connection, because the output will be on with either of these switches. Either this or that, we will have an output. Okay. Right. Would the lamp glow in each of these circuits? Yes. The lamp will glow. Okay. Because the lamp is part of a complete circuit that includes the battery. It's a complete circuit. Without this open switch, even without this open switch, this circuit is complete. Even if you close either of the switches, this circuit will be closed, because the circuit will be complete, because current will flow where it finds its path. If it doesn't find its path here on the open switch, then it has another alternative route where there is a closed switch. Will the lamp glow in this circuit? Let us look at this one. You have a series connection of switches. A is open. Will this lamp glow? Grade 9? No, it will not glow, because now this switch, it will act as a circuit breaker. It will break the current. There's no flow of current here. So current doesn't come to the output. Very good. No, the lamp is not part of a complete circuit that includes the battery. The lamp is not in a loop that is open. Okay. Will the lamp glow in the circuit below? This is the answer. Now let us check. You have an output in between two switches. The answer is no, the lamp is not part of a complete circuit that includes the battery. The lamp is in a loop that is open. This circuit is electrically equivalent to the one on the slide above. Okay, it is a series connection. It is just like this one. All right, a kettle must be switched at the wall. It must be switched on at the wall plug first, then at the kettle itself. You know your kettle's name in the kitchen. Fill the truth table to show the opposite, all the possible combinations. Here is the truth table. You have your wall plug switch and the kettle switch. And when these switches are all open, there is no output. When the plug switch is open and the kettle switch is closed, still no output. When the wall plug switch is closed and the kettle switch is open, there is no output. For an output, you must close the wall plug switch and the kettle switch, then you have your output. So this one is like this one. The circuit for the kettle is like this one. You have your switch, you have your power source, the mains, the plugs. You have your switch for the switch of the plug, the switch of the plug, and the switch of the kettle. Then that is the output. So if either of them is open, you cannot get an output. Is this an AND function or an OR function? Explain your answer. Is it an AND or an OR? Grade 9. Do you understand the AND function and the OR function?
Yeah.
Yebo, come, my darling. Okay, I'll read your chat. Is it an AND function or an OR function? I want to know that. Grade 9? It's an AND. Explain. Oratile. How do you explain it? It's very simple. For the kettle, it's an AND function. For the kettle to boil, you need to switch you need to close. We say we close, ne? You need to close the first input and the second input so that you have an output. Your kettle cannot boil if the wall plug is switched off. Kettle cannot boil if its switch is off. So both the switches must be on for the kettle to boil. So it's an AND function, okay? An OR function is like the parallel connection. That parallel connection that we had in this circuit, where you have your light shining, even if one of the, like this one, it's an OR function because this light will be on, even if one of the switches is off. This light will be on only if only one of the switches is on. So it's an or function, but the kettle is an and function. I want you to understand that, ne? Grade 9? I hope you do. Okay, now let us look at current, voltage, and resistance. What you see in front of you here is what we call a multimeter. Okay, we have different tools that we use to measure voltage, resistance, and current. But we prefer to use this one because it measures everything. It measures voltage, resistance, and current. So we call it a multimeter because it has a multifunction. Okay, because we do have tools which measure voltage only and which measure current only, but this one measures everything. So when you can look at this, you will see there it's holding a resistor. When you can look at the red lead there, it is attached to that port, which has a symbol for ohms. It's a V and ohm, a V and omega sign. Okay, the omega sign is the one that we use for ohms, right? And then the black one, although we cannot see, the black one is normally connected to COM, to common. That's where you connect the black one. And then that is how you measure the resistance of your resistors. This is a resistor there between these coil clips. So it is measuring resistance in this case. And you must not miss the connection. You must not maybe, you know, if you maybe by mistake, you would put this red on common. Black is common. You insert the black lead into the black port for common. And then you insert the red one on the V omega one, okay? So that is what you use to measure voltage resistance and current in a circuit. Now, how to use a multimeter, I've already explained that to some extent. Right, identify the section labeled ohm, with, the one I said has an omega sign, okay? Connect the red test lead on the VMA terminal and the black on the COM terminal. That's how you connect it. Adjust the function selector to, let me show you the function selector. This is the function selector, this one. You will adjust it. Adjust the function selector to ohms here on the multimeter, here around the adjustment selector, you will find an ohm sign. That is how you measure resistance. Connect the leads of the test leads across the unknown resistor as shown. Maybe you get a resistor, you don't know the value of the resistor. You do this connection with your crocodile clips. So this is just a magnified image of what you see here. And then the screen of your multimeter will tell you the value of this resistor. What is the value of this resistor? 462 ohms, 462 ohms. We measure resistance in ohms, okay? That's how you use a multimeter. How to measure voltage, right? You identify this, you do your connections, identify the section labeled DCV on the multimeter, okay, in this picture. And then you connect the red lead like I showed you. And then you set the meter on the highest range of voltage. because this selector, around this selector, you have units for voltage, current, and resistance. So you will adjust this to the highest value of voltage. Okay, and then you connect the other leads to the test of the test leads parallel across the part of the circuit where the voltage is to be measured. You connect it parallel. You don't connect the multimeter in series when you are measuring what? Voltage. You connect it in parallel. Red test lead to positive and black test lead to negative. Read the voltage from the display, from the screen. This screen will show you the voltage. The screen of the multimeter will give you a value. You know, I like the multimeter because it gives you a value accurately. It even gives you the decimal, okay? The multimeter is digital. You know, it's best to use a digital multimeter. You do get these tools in analog and digital, but I personally prefer the digital one because it gives you the exact value. Okay. How do you measure current? When you measure current, you put your leads. You see, this connection is in series. You measure current in series, okay? You see, it is in series. That's how you measure current. Right. When you measure current, identify the section labeled DCA on the multimeter. Here, DCA, you will find the black is always on the COM. Here you are measuring voltage, but then you come here to measure DCA. What is DCA? DC, direct current. Okay. Why do we say it's direct current? Because we are measuring current of a cell or a battery. If we are measuring current, perhaps of the mains, of the plugs, that is a different current. It's called alternating current. So DC means direct current. It's the current of the battery. So that's what you will select here. Connect the test list to this symbol, to that terminal, and the black lead to common. If the current to be measured is between 200 amps and 10 amps, connect the test lead to the 10A terminal. Okay, adjust the range selector to A ampere region because you are measuring what? Current. If you are measuring an unknown current, start from the highest range, then adjust to a proper lower range for the best accuracy. You know why? Because you see, because you're going to adjust it to the highest range. If it is very small, it will give you a lot of decimals. So you will go on lowering and lowering the adjustment on this selector. You will lower the adjustment on this selector until it gives you maybe a direct value that doesn't have many decimals. Maybe you can get a 0.0 what value. Then you want to adjust it lower. Right. And then read the current value from the display. Now, when you measure current, as I said, you remember, the leads must be in series. Okay. Another tool that we use to measure current is the ammeter. We say it's the ammeter because it measures amperes. Okay. If you can look where we position the ammeter in the circuit, we make a series connection of the ammeter and the other components. In this circuit, we have the power source. What is the value of this power source? Who can tell me? How many volts are here? Grade 9? How many volts are here? How many volts is this power source? How many volts? 1.5 volts. Okay, we know that one cell is 1.5 volts and we call it a cell. We don't call it a battery, we call it a cell. That's how you draw a circuit diagram with one cell. Okay, now, when you look at this, this is the graphic symbol for the ammeter. This A, it is the graphic symbol for the ammeter. Okay, and then this is a graphic symbol for the resistor. We label the resistor, resistor 1. What is the value of this resistor? It's 500 ohms. We measure resistance in ohms. So this circuit has a power source of 1.5 volts. It has an ammeter. The ammeter is connected in series with the other components. Okay? Then, you draw up your circuit like this. You see, this is a resistor. There's another symbol for a resistor, ne? Because if you Google circuits, you will find a zigzag symbol for resistance. Okay, it is acceptable, and even this one is acceptable too. So this is how you connect an ammeter. Okay. An ammeter is always connected in series with the part of the circuit for which you measure the current, so that it measures the full current through that part of the circuit. It has a very small resistance so that it does not change the current in the circuit. Okay. Now, a voltmeter is unlike an ammeter. A voltmeter is connected parallel. You see, we want to see the voltage in this circuit. Then we are going to have a parallel connection. This is a parallel connection. A voltmeter is always connected in parallel in a circuit. An ammeter is always connected in series in a circuit. Okay. Very little current flows through a voltmeter since it has a very high resistance. You see, if we could connect the voltmeter inside the circuit, the reading would be incorrect because it would be affected by its own resistance, because it has a high resistance, the voltmeter. So it's not like the ammeter. The ammeter doesn't have a lot of resistance, so it gets an accurate reading. But the voltmeter, if we connected it in series, it would give us a false reading because it would offer resistance in the circuit. For now, it is good because the resistance is only offered by this resistor. So we don't need another resistor in form of a voltmeter, but we need a reading to measure the voltage of this circuit. So that's why we connect it in parallel. So if you were to be asked, why do we connect a voltmeter in parallel in a circuit? Your answer would be, we connect a voltmeter in parallel in a circuit because a voltmeter offers high resistance in a circuit. So if it was connected in series, it would give a false reading. Why do we connect an ammeter in series in a circuit? The answer is, we connect the ammeter in series because it doesn't have a lot of resistance. It offers very little resistance in the circuit. So its reading of the current is reliable. Remember, the function of resistors, okay, I will teach you, I'm still to teach you about resistors. The function of resistors in a circuit is to restrict the flow of current. So if you connect a voltmeter because it has high resistance, it will inhibit the flow of current in this circuit and the reading would be incorrect. So that's why we always connect it in parallel. Thank you, grade 9. We'll continue looking at other components and other connections. I hope you have a lovely day, a lovely evening actually. The sun is about to go down. Have a lovely evening. Thank you. Bye.